We're back here with lesson 9.5 regarding SOHCAHTOA. My apologies regarding the video because it looks like there's just some issues with the live stream, and I'm just a little bit frustrated with that. I don't know how to resolve it. It looks like it is actually uploading to Twitch, so I'm gonna go ahead and just uh finish this live stream for you guys, and then hope this works out for the best. So SOHCAHTOA. Here we go. Here is the mnemonic. So SOHCAHTOA stands for the following. You guys have already looked and investigated, I'm sure, as we discussed in class, the following buttons that appear on your calculators, which was sine, which is the SOH, which is this button, okay, sine. And then you see the cosine, which is this button in your calculator, COS. And of course, we've already seen on our calculators tangent, which is TAN. Sine is equal to, it's the ratio in a right triangle of the opposite side from the angle to the tangent. Sorry, to the tangent, goodness gracious, to the hypotenuse. And cosine is equal to the adjacent side to the hypotenuse. And then tangent is equal to the opposite side to the adjacent side. And it's a mnemonic to help you remember it, right? The O over H, A over H, and O over A for sine, cosine, and tangent, which are easy enough for us to remember because the calculator remembers SIN, COS, and TAN. So let's go ahead and we're going to construct just one right triangle here, and then we're going to relate this whole concept back to what we've been doing. Okay, so here we go. That's a really well drawn triangle. You guys can see how great I am at drawing. All right, and we have R, S, and T. And then I'm going to go ahead and give the dimensions of 39, 36, and 15. Right. Still trying to make sure that my live stream is working properly, but I'm having an issue right here. But I'm available on the channel if you guys are available too. All right. What we're going to do here on this problem is we're going to find the sine of R, the cosine of R, and the cosine of S. All right. Here we go. It's going to be a fun one. Move this guy up ahead. So we have the sine of R. And the sine of R from the angle. Sine is the opposite over the hypotenuse. So the sine of R would have to be 36 over 39. All right. So 36 over 39, which is going to be equal to, you can simplify it if you want, right? Both are divisible by 3, which would be 12 over 13. And both things are going to be correct because remember, these are going to be similar triangles. So either way, if we were going to find the inverse sine of R, as we talked about the inverse function, it's still going to lead us to the same exact angle measurement here for angle R when we solve for it. So next, let's go ahead and solve for the sine of S. We're going to solve for the sine of R shortly here, okay? So we're going to solve for the sine of S. We're going to solve for measure of angle R, that is, by using the sine of R. So the sine of S. So remember what sine says, right? So now we're from the angle S, okay? Sine is still opposite over hypotenuse, so we go to the opposite side, which is 15, right? Over the hypotenuse, right? Opposite the right angle, and that's 39. So that's just simply the fraction 15 over 39. All right. Now, Let's go ahead and do the cosine because it just wants the ratio. It's not asking us for more. This is just like those first four problems we did in class on the last assignment we did for lesson 9.4. So the cosine of r is going to be, so from the angle r, oh goodness gracious, I'm like just going crazy there. Okay. From the angle r, I'm sorry, the keyboard went crazy. Cosine, so it's the adjacent side, right? Because this guy 36 is opposite, so there has to be this one versus 39 is the hypotenuse always, right? For this triangle, it's opposite this angle T, which is the right angle. Cosine of r would be 15 over 39, adjacent over hypotenuse. And then, for fun, we did the cosine of s too. Oh, I'm sorry. We were supposed to do the sine of s. Forgot to put that down there when we were working. So we have the sine of s, sine of r, sine of s, cosine of r, and then last but not least, we're going to do the cosine of s. And then we're going to do a little discovery, which I think you guys can already see because of these two, cosine of s and the cosine of r, being the equivalent. So, of course, the cosine of s. Gentlemen, I want you to think, are these going to be the same since these two are the same? And I think you're going to have a it's not an unpleasant surprise, but it's going to be maybe not even a surprise at all. They are, right? Cosine of s from the angle, the adjacent over the hypotenuse, which is going to be 36 over 39. Which is what we discovered. That the sine of one angle is the cosine of the other. Now, let's go ahead and find the sine of r. Let's find what angle r is equal to. So remember, let's take this here. And we're going to say the sine of r, which is 36 over 39. Okay? Which, when you put them into your calculator, is about equal to, not equal to, but according to your calculator, the sine of 36 over 39, or the sine, again, we did 12 over 13. You can do, it's the same exact thing, is going to give us a decimal approximation, which we're going to take to 4 decimal places, which is about 0.9231. All right. Now, in order to solve for r, because we want the sine of r, my apologies, guys. I keep on having these things not write themselves. Sine of r. So we got to solve for r, get r by itself. So the sine of r, we have to take the inverse sine, right, of this guy. Goodness gracious, it's about equal to. Sine of r is equal to 36 over 39, which in this case is about equal to 0.9231 when we do it. So then I'm going to take the sine of r, which is about equal to 0.9231, and then I take my inverse sine of both sides to get r by itself. So I'm going to take the inverse sine of 0.9231, which is the inverse sine I could also take of 36 over 39, right? This is what I'm really going to do here. And when I do this factors out, and I'm going to have angle R is about equal to, and gentlemen, I hope you're really excited for it. My daughter pointed it out to me tonight that this is 67 degrees when we actually punch this into the calculator. 67. Okay, next. Let's write the sine of 36 in terms of cosine. And this is going to be more interesting than you I thought, because we had this where we had like the sine of one was the cosine of the other, right? So it has to do the same. It has to do with complements here. So whatever it is, remember the sine of 36 is going to be just the supplement of its cosine, or excuse me, the complement of its cosine, right? Complement. So it's going to be complement, which is 90 minus 36, which is 54. Okay? So what just means it's going to be the cosine of 54. And if you really care, I want you guys to punch this in to your calculator. The sine of 30 and the cosine of 54. Okay? Both, when we actually put it into our calculator, I want us to actually do this real quick because this will be fun. All right? Trig. Oops. 54. The cosine of 54 is 58.77. All right. And then of 36, the sine is also the same exact value, 0.5878, right? 778, which is 78. All right. Awesome. Very cool. Little a little bit of a connection for you guys. Oops. It's about equal to what is 0.5878. Very cool. Awesome. All right. Next. Last two examples we have here. We have y, we have x. This is 35 degrees, and this is 53 as a side length. And we're going to solve for x and y. Now, a couple ways we can do this, okay? And the first one I'm going to use has to do with so, right? Because let's go ahead and solve for x first, okay? Let's go ahead and solve for x. So if I have x, actually, x isn't going to be so, x is going to be ka, right? It's the adjacent right here and the hypotenuse, 53. So it means that the cosine of 35 of the angle from the angle is equal to the adjacent side x over 53. Now when I multiply, right, to solve for this guy, to get x by itself and multiply by 53, factors, and I'm going to know that the exact answer is 53 times the cosine of 35. And that's x. Boom. Which you can punch into your calculator. Okay, let's do it. I'm going to take 35. I'm going to take that cosine, which is that number, 0.8191, right? And I'm going to multiply that times 53, and that's going to give me 43.41, or about 43. Okay. Next, for y, all right, a whole new deal. For y, let's use so, right? So we're going to take the sine of 35 as the opposite in the hypotenuse. So the sine from the angle 35 is equal to y over 53. Again, to solve, we're going to multiply by 53. And we're going to see that 53 times the sine of 35 is equal to my y. Boom, that's the exact answer. And what's it about equal to? Well, let's actually figure it out. Let's go ahead here to our calculator. I'm going to take, my calculator requires me to take 35 before I make it do the sine function. So sine of 35 is how I'm going to have to input that, right? You guys can see that. And then I'm going to have to multiply that times 53, and that's going to give me 30.39, which is 30.4 to the nearest tenth. Okay, Excellent. Last part of our lesson here. Let's figure out, for a guy, how do we use this? I'm here. This is me. And I'm on the street. And I got a building here. This is a very well drawn building here. And there's me, a very happy stick figure, right? Look at this face. You can tell it's me because it's smiling. And I clearly smile all the time. And there's these very well drawn, windows, right? That's how you guys typically see windows. There's this thing right here. There's a little doorknob on it, on the door. And we're standing downtown. And one thing we can do is measure the shadow of a building, right? When we have the sun's rays coming down and creating a shadow, which we could actually measure. Oh my goodness, that was really aggressive. Okay, a shadow we could really measure right here, okay? Which is going to be 40 feet. All right. So as they say, it's ghetto, but it works, right? I can use this trigonometry in a very rudimentary fashion to solve a problem for me in terms of the building's height. Because all I need to do, I can't climb the building, but I could go here with a tape measure and measure this 40-foot distance from me to that building, right? So, the thing I can measure too with a speed square, I'll show you guys this in class, a little tool. You can buy this at a Home Depot. I got a 42-degree angle, all right? That's where I've got the shadow cast. And this is what's called an angle of elevation. Obviously, an elevation because it's going up, okay? So I have this angle of elevation. And I want to know roughly two things. From me to the building directly, and then the height of the building. Okay? So, let's figure this out. Well, one thing I could do is I could use tangent, TOA, right? Because I've got opposite and adjacent. And I could say the tangent of 42 from the angle is equal to x, the opposite side over the adjacent side, 40. And to get x, I'm going to multiply each side by 40. Cancel, or factors, and I have 40 times the tangent of 42 is equal to x. And that is the exact answer, but nobody really does it this way, right? They're not going to say, oh, it's 40 times the tangent of 42 feet, sir. Don't you know what that is? No, they're going to say this is about equal to 36, right? So they'll say, right, because it's 36.016. So it's about this many feet, okay? So the building's about 36 feet high. Now, let's take a look here. Let's find y. Now we have to figure out what do we have. We have this known and this known. And I have to figure out what this is right here, y. So what parts are we working with? So this and this are the adjacent and the hypotenuse. So I'd say the cosine of 42, right, from the angle is equal to the adjacent, which is 40, over, right, the hypotenuse, which is y. Now, gentlemen, could I take this and could I solve this really quick? Could I solve this using sine instead? Now, could I say that the sine, because I know x is this, so could I say the sine of 42 is equal to 36, right, over y? I don't want to do it this way because this is what we're going to talk about, which is we've talked about before, which is the 36 is an approximation. We talked about this before, the King James Bible, right? The approximation of an approximation. It's kind of it's kind of just doubly bad. So we're gonna go ahead and go back and try to solve this thing here. Multiply both sides by y. That's gonna factor out. So I'm gonna have y times the cosine of 42 is equal to 40. And then to get y by itself, I'm going to divide by the cosine of 42, which is just some decimal number. And this guy will factor out, and y will equal 40 over the cosine of 42. And then that's my exact answer, which I can then put into a calculator and get that y is about equal to 53.8 feet. Okay, right? Again, putting that into the calculator, right? 40 divided by the cosine of 42. 40, and we're going to divide by 42. Cosine. Oops. Gotta go back here. Where'd it go? I hit enter one too many times. You guys can see on the right side is 53.882, right? 825. Over on the right side of the screen, that's this guy right here. Yeah, that's what we want. Okay. I'm sorry, I hit enter too many times on my calculator. Okay, that's all I got for you guys. I will see you in class.